take his own time. You're ready to write a lot. You're not going to be writing a lot. You'll be talking a lot, though. Oh, Jen, sorry. Hey, you look like you're disappointed.
She's like,
Well, I need to write stuff down and do stuff.
Okay, just stick with. Like I said, this is where the game changes, right? This is why calculus exists. This is up until this point, all you've ever done in math is algebra and trig. Well, a little statistics. Who cares? Like algebra 1 is algebra. Geometry, there's a lot of trig in there. Some other shape crap. Algebra 2 is all algebra. Pre-calc is all algebra. And trig on the unit circle. Now, this is different, it's a whole new thing. How many of you had physics? That's it?
For like about how long is it?
She had it for like 2 days.
Like 3 days
I
actually.
was hoping for more. 'Cause having like a little bit of physics background will help. We're going to reference physics a lot.
I told him to
Do
join me.
lots of physics problems. Like the first two examples. It's easy physics though, so like you'll hopefully understand. Or maybe in physical science you learn about like acceleration of gravity and like how to calculate how fast things go.
yeah, we
That
did
was
that for
freshman
senior year.
Yeah, okay. As long as you've heard about it before. But before I give you the mathematical definition of a limit, we're just going to do a couple examples and try to get to what they are by looking at these examples, because it helps understand. If I just give you the math definition right now, it will not make any sense at all. You'll get mad.
Math definitions don't make
Yeah,
any
let's
sense.
go. So let's talk about speed. We're going to talk about two different kinds of speed. But first, let's set up the thing. Let's say it's lunchtime, and you, huh?
Yum.
Yum. You're going to go. Where do you want to go? Burger King, Taco Bell.
Pizza Hut.
Pizza Hut.
That's
No, not Pizza
Olive
Hut.
Garden.
too far.
Taco Bell. I thought you meant
Your
anywhere.
choices are in Moses Lake. That's it. Sorry.
Rock Top.
Taco Bell.
Rock Top.
Okay, we're going to Taco Bell.
Yeah.
Okay.
We don't have time to go to Rock Top. It's too long. Technically, you don't have time to go to Taco Bell either. But whatever.
Anyways, Taco Bell is close.
You go to Taco Bell. Let's say the trip there takes you. What's it take to get there? 20 minutes from here.
Yeah.
Yeah. About.
12. Actually.
From the school, it's probably 20. By the time you get out to the highway.
I think the most you can make is maybe 17, but 20 is good.
Yeah, 20 is realistic. And let's say the total distance. What is how about? That's about 15 miles, right?
Yeah.
'Cause the highway portion is 12.
I'd say about 14, but
Close
yeah.
enough. 15 miles. It just doesn't need to be. How fast were you driving?
60.
65.
65.
70.
Really?
Well, the speed limit is 60, but we probably go 65.
The speed limit is 60 the whole way?
No.
No. You go 25 to 35 to 55 to
Yeah,
60.
you got a whole bunch of different
Or
speeds.
you
Go
go
like
25.
Then you break down to
45.
So you were
45.
driving a whole bunch of different speeds to get there.
Yeah,
right?
yeah.
You weren't just, you didn't leave here and drive 65. That's
Yeah.
not possible.
Yeah. Maybe. I mean,
Because you'd have to turn. And,
there double.
then,
65 to be interesting.
okay, so we got to talk about what kind of speed are we talking about. When I say how fast you're driving.
You break.
So there's two different kinds of speed that we're going to talk about. The first one is average speed.
I want Taco Bell, Mom. Me too.
I can get there and back before lunch.
All right, bring some.
And then the second one is your instantaneous speed.
No need to.
Ever heard that word, instantaneous?
Yeah.
Yeah.
It's a good word. Bust out that word every once in a while. You sound smarter.
Man, I like this way this is
At least once a
going.
week.
I like where this is going. I know this stuff.
All right, you'll be teaching.
Can you
us.
tell me what either one of them are?
Yeah, average speed is your speed over a certain amount of time, and instantaneous speed is how fast you're going at that exact moment.
Yep.
All right, do we write that down?
Instantaneous speed is, we'll start with that one. That's how fast you're going at any exact given moment in time. That's what your speedometer in your car tells you. So like, as you're driving down County Road here, you're probably going 25, maybe 20 if it's the
Or
yellow
30.
light is blue.
Oh, I hate that.
I travel 30
Right?
times.
That's your
too slow.
at that moment. Right when you go past Scone, you're probably going 40 because you're speeding up to get to
To 55.
55 unless you already got the pedal to the metal. You know. You go past Caballero's house, you're probably doing,
60.
you should only be doing
60.
55.
You can go 5 over.
You can go.
That's
Nine-
what we all
nine
taught
is
with
better
Richard.
than
You can go 5 over.
Well, you see, they usually set the speed limit for a reason.
My mom
The
always
voice
says
of
you
reason.
can
Because
go
that's
8
the
over, but
limit.
if you go 9, they will pull you over. Don't go 9.
They can pull you over if you're going 1 over.
Yeah,
Okay,
like
yeah,
it.
but
They're gonna
most
pull you
cops will
over
pull
if
you
you're
over.
going 40 over too.
I wouldn't
Anyway,
pull you over.
So that's your
20
instantaneous
over.
speed.
It's okay, no.
That's your speedometer.
I'm for it.
Why so far away?
That's whatever it says.
My court date.
Your average speed, how do you, average speed is just, you,
Distance divided by time?
yeah, you take all your, you could take all of your speeds the whole way and then divide by however many there were, but there's infinitely many. Or just your total distance divided by how much time it took you to get there. That's your
Speedometer
average
what?
speed.
Read? Red?
Speedometer, I just put speedometer reading, I don't know, it's whatever your speedometer says. So how can we calculate average speed here?
Time over distance?
Time over distance.
Distance over time.
Or distance over, how do you know? Which one
Yeah,
is
I
it?
don't. You take.
Have you ever seen dimensional
time over
analysis?
No.
If
No,
you
it's
did
not.
time
Distance
over,
over
don't
time.
write this down. If you did time over
It's
distance,
distance over time.
20 minutes divided by 15 miles, your answer, the units will be in minutes per mile. Is that what we want?
Miles per minute.
We want miles per minute,
So
or even
miles-
better, let's go
Distance
miles
over-
per hour.
Yeah.
Distance over
Yeah,
time.
distance over time, right? That's average speed.
I was right the very first time.
Distance over
You're
time.
just gonna just.
So the 15 miles
Over
over
Point
20 minutes, how much of an
3.
hour is that?
point,
1, 4,
it's a third.
It's a third of an hour.
0.33.
60 minutes an hour, right?
15, 30, 45.
20, 40, 60?
There's just one fraction.
Yeah, I know. I did that on
Oh,
purpose,
20.
that it was 20 minutes. Because 15 minutes is easy.
About
that's a quarter.
45.
So 1/3 of an hour. Flip and multiply, right?
So you have 60,
15 times 3.
60, 45.
45
over-
miles per hour is your
Oh, yeah, over
average
one.
speed. So that takes into account the places you were going 60, the places you were going 25. It all averages out to about 45 miles per hour. Makes sense, right? Questions on that? Average speed versus
Wait, how did you get
instantaneous
1/3?
speed. That's 20 minutes.
20 minutes is, okay.
1/3 of an hour. Questions on the difference between average speed and instantaneous speed. All right, let's do another example. Still dealing with speed here. You drop a rock off a cliff, you know, everyday situation. You're out at Goose Lake and you're going cliff jumping. And you're going to drop a rock and you're going to do some calculations about this rock falling before
I
this.
miss Heart Lake. That was so fun. Dude, I can't believe I jumped off that.
9.8.
First thing we're going to do, shut up, Wall. That's meters per second squared. We're going to be in feet.
Okay,
Saying
what?
it's squished.
Wait,
Meters
we're
per
doing
second
feet?
squared divided by the square
You know
root of
what it is
12.
in feet?
No, because that's stupid.
32.2 feet per second. Anyway, so let's find the average speed during the first 3 seconds. Average speed.
Sorry, I'm just kind of excited because I finally know what you're talking about.
Yesterday he was like,
But we need more information than this. This isn't enough. It's just arbitrary. It's what I picked. Let's find the average speed for the first 3 seconds of the fall. After 3 seconds, see,
Doesn't it get faster?
yeah, I would assume so.
well, it gets faster and faster, but
Then it goes into water and you lose it.
we know this. We know f of t equals 16t squared, where f of t is distance
Ew.
and t is time.
Why'd you use 16?
I'll tell you in a second.
Okay.
Just don't remember right now.
Okay.
For lunch?
This is just approximate. This is experimental here. This is real. If you take a hard, solid object and drop it, the distance will be equal to approximately 16 times the time it took squared. In feet. This is in feet. That's important. And that works for anything that's any short fall. If it's a long fall, if you drop something off a building, eventually as it's falling, what happens?
It reaches the maximum velocity.
or wind resistance starts to slow, it doesn't slow it down, but it doesn't increase in speed as fast. You know what that's called? Increase, how fast you're increasing
So
your
like
velocity.
when you go,
Acceleration.
Acceleration, you know about acceleration?
so like when you go skydiving, or you
Yeah, when you go skydiving and you jump out of a plane, you're falling faster and faster and faster and faster. Eventually, you're not falling any faster. You're only falling as fast. It's called terminal velocity. The wind resistance and the effective gravity have evened out on each
I
other.
would never
And
go
you're falling the same speed.
I
At a
was looking for
certain-
that word because we just learned that.
At a terminal velocity? Yeah, at a certain point, you're not falling any faster. You're just going the same speed. But if we're just talking about little short distances, little short times, we know this. We don't have to think about wind resistance. This works. So go find the average speed of the first 3 seconds. How are you going to do that?
Plug
Time.
in for T
Plug
So
in
3 seconds, but it's in,
seconds.
instead of a minute or an hour?
You plug in
Your time,
three,
what?
three,
Yeah,
First 3 seconds. Oh, this?
Yeah,
That's time in seconds.
inside, okay, so plug in 3.
Sorry.
Oh, yeah.
So 16 times. Wait, is it T squared? Never mind. That was a stupid question. Do you want it?
Sure, what'd you get?
144?
144 what?
feet.
Seconds.
No, yes,
Seconds.
144 feet.
104. I didn't. I wanted the average speed.
Oh,
Feet is
well,
not
I don't know what the
speed.
speed is. Oh, wait, no, yes, then you do 144 divided by 3.
There, that would work. Right? Average speed is distance over time, right?
Yes.
You know how many story problems I've done this? and
Or,
I've
check this out. If f of t is distance, this is like y.
Okay, this is nasty now.
Isn't that the change in y over the change in t? Right? Remember the little triangle means change in y.
Yeah.
Y is distance. So the change in the distance divided by change in time.
That's your speed.
That's your average speed, right? So to do that, I'll do 16 times 3 squared. Really what you're doing, you're not really writing this part.
So is it 48 seconds per feet? Feet per second? How do you say that?
If I do this, 3 squared is 9 times 16, you get 144 feet. That's how far it traveled, right?
Uh-huh,
Divided by, it took 3 seconds. So the rock is traveling
48
48 feet
Seconds.
per second.
feet per second.
You could convert it to miles per hour, but that's usually when
So
it's
you
a
do
car
distance
problem.
over time always.
Distance over time, average speed, right? 48 feet per second.
Miles per hour.
It's like 3S in the water, not 3.
Yeah, 3 seconds. My S's and 5's look the same.
Yeah,
All right, so the math way of writing this would be, if I'm going to use function notation, I would have f of t plus h minus f of t over h.
What's this for?
Average speed still.
Okay.
This is what we were doing in our head, but let me explain what all this is. F of t is still
Distance.
distance. T is still time.
H is height.
H is elapsed time.
So you're doing the distance plus the elapsed time minus the distance divided by.
No, hold on.
That's.
You have to, first thing you have to understand is the difference between time and elapsed time. Here, let's see, should have figured out how. Let's talk about our trip to McDonald's.
Talk about.
Taco, oh, that's right, Taco Bell. I never
I'm not going to McDonald's.
one of those places.
Ew.
Yeah, I hate McDonald's. But our trip
Make you
there,
sick too?
huh?
Does it make you sick
Yeah,
too?
it's
It's so greasy.
Food.
I mean, like the fries. Anyway, who cares?
Makes me not.
If we're talking about our trip to Taco Bell, and we're talking about finding the average speed, we could take find the average speed for the whole trip. That's where we just took the total distance divided by the total time. But let's say I said, find the average speed while you were on Highway 17. So I don't care about your trip out there. I just want your average speed from the time you got out to Highway 17 to the time you got to Taco Bell. Okay, well that would look a little different, wouldn't it?
You say Taco Bell, funny. Taco Bell.
He enunciates his words.
Let's say we had a graph. Here's your time. Here's your distance from school. And I'm going to simplify this a lot. So you're going to leave the school and you're going to drive really, really slow. So your distance isn't getting far away very fast. And then you're going to start going through the neighborhood, so maybe you're going to go a little faster. And then you're going to hit a stop sign. And then let's say now you're going past the potato plant. And then you're going to stop sign before 17. And then once you get on 17, it's going to grow a lot faster, right? It's going to get faster and faster and faster. Okay? So something like that. All I'm using this for is to explain the difference between time and elapsed time. Here's 0. Let's say it takes you, 5 minutes to get out to the stop sign. That's about right, to get to 17 from here. By the time you get out of the parking lot.
I feel like it takes me like 10 minutes.
It might be a little longer. I don't know. Just making this up. Who cares? The point is, time is the total time since you left. It's the beginning. But elapsed time, if I said, find the average speed once you got on Highway 17. So let's say here's Highway 17. And then you slow down, and here now you're at Taco Bell.
Wait, why is she speed getting faster and faster and faster? Don't you stay at 16?
Your speed isn't, your distance from school
Oh, yeah, okay.
is getting,
Oh.
it'll level out at a certain point. Right? You're not going to keep getting farther away faster. Let's not get in too far into that. Just, all I want to talk about is time here. Yeah, this may not be 100% accurate. Your total time was 20 minutes, but if you wanted to find the average speed only on Highway 17, you would use this chunk right here, which would be the elapsed time, which would only be 15 minutes. Elapsed time is just the time since an event that you can name. Like the elapsed time since I hit Highway 17 to Taco Bell was only 15 minutes, even though my total time was 20 minutes. Right? So elapsed time is just a smaller section of it. So it's like, oh, I'm only talking about this piece right here. I'm not talking about the whole trip, or if you're dropping the rock, I'm not talking about the whole time from when it left my hand to when
So
it hit
that
the
3
lake.
seconds
I'm just
would
talking
be
about this
elapsed
little
time?
second chunk. This was the elapsed time. This was the time, it wasn't from when I dropped the rock to when it hit the lake. It was just from when I dropped the rock 3 seconds later. That's elapsed time. Total time would be the whole big picture. Okay?
So that
I
equation
failed.
is just to find average speed.
What?
So that equation right there is just to find average.
This is to find average speed. Yeah. So, we did this. Here.
Plus here.
Whether you know it or not, you plug stuff in, and you took the distance over a certain elapsed time. You subtracted your starting position, right? Which was 0. And then we divided by the elapsed time from 0 to when the rock hit 3 seconds, right? That's how we got this.
Okay, I understand that. Yeah, that makes sense. These?
They're like that, but they're different.
Yeah, I got these. I don't order them for like.
Talk about the same rock,
I don't order the ones that like old.
but now we're going to find the instantaneous speed. At the time of 2 seconds. So this is like asking exactly how fast were you driving?
I have no, like,
Yeah, you said two.
You said two, but you wrote
oh, okay, I get you.
I want 3. I wrote 2 on this paper, because I switched it from 2 to 3. Because when you use 2, something happens, and if I use 2, you'll think that always happens, but it doesn't. So I use 3 to avoid that.
Like 2 times 2, 2 plus 2 is the same.
Yeah. And then you would go, oh, 2 times 2 is the same as 2 plus 2. And it's like,
No.
no, so that's why I used 3 instead, but on here, because I didn't realize it till later. All right, how are we going to find our instantaneous speed at 3 seconds?
set it up equal to.
We don't have a speedometer.
Time divided by distance.
Time, just, other way around.
No, that's why I was switching it. I thought it was different. This is divided by
Speed
time.
is always distance divided by time. But if we're talking about at the instant of 3 seconds, could we calculate how far it had fallen?
Distance divided by,
But what would the time be at 3 seconds?
Make my day a little
What would the
better.
elapsed time be at 3 seconds?
1
3
second.
seconds.
Because you just want that 1
Is there
second,
still
right?
3?
No, the whole big picture, this is during the 3rd second, but how much, see, this is, there's a problem here.
Can you draw a picture?
Yes, I can.
Thanks. Not there, on different screen.
I don't really know.
he's like, yeah, anything, sure thing, boss.
Sorry.
No, I had pictures, I was like, show graph and table if needed. Okay, we need it. Here's our position.
Oh, FUT, not X. Come on, man. It's okay.
First time. Seconds. Hold on, I'll let you guys graph that. Should be able to.
It's a problem.
It is. But what's, is it gonna be a full
It's gonna
travel?
be really skinny. No, really
It
wide.
is gonna be skinnier than a normal, but we can, what, how do we decide what to scale over here?
T? Go by
We're
4.
only gonna go out to about 4. So 4 squared is 16, 16 times 16 is
You already know. Oh, no,
200 and some, 256?
How is this? Yes.
Yeah. So I need to go, so I'm gonna go by
20.
50s.
20s, so let's go 20s, we can go 20s. There's 100, 200. You don't have to write all the numbers in. Just know you're going by 20s, and that's feet.
Why did you put position?
It's where it's at, or distance from your hand.
Okay.
Position, it's just, it's where it's at in respect to your hand. Because technically these are gonna, if you did, actually position could be negative. If you think of your hand as 0, position is getting below your hand.
That makes a lot more sense to me, actually.
Really?
Yeah,
I said, since I wrote position, we could graph it that way to where these are negatives. Because if you think of position, if the rock's in your hand, the position is 0, but as it's going down, the position is the distance. We could always put, let's just make a distance then. Sure. That way you don't get the distance it's falling.
That makes more sense to me.
Yeah, the distance it's dropped from, that's 0 seconds. How far is it falling? 0 feet. Hey, let's make a little table too.
Let's just kill all the birds with one stone.
At 0, we've gone 0 feet. After 1 second, how far has it fallen?
12.
Well, yeah, 16.
16.
This is your position function. This is your distance right here. 1 squared, 1 times 16, 16. 2, 3,
2
Sadie's side, 2 squared is 4, 64. 3 squared is 9, 9 times 6 is 144. And then 4 squared is 16, 6 times 16 is 256. So now, let's just draw our little graph.
Question.
Yes.
Why are we only doing 1 quadrant instead of 4?
Will there be negative time?
No.
No.
No. in this case, will the distance ever be negative?
Yeah, 'cause you're just measuring.
I mean, the distance from your
One
hand
to
is just
another.
gonna get bigger and bigger, and it's gonna hit the water, and it's gonna stop, or it's not gonna.
So you're just going.
You can go down in the lake, but then it changes. Well, that's not good enough. Bro, all we were caring about is the first few seconds after it drops from your hand.
Okay.
So, after 2 seconds, 64, right? This should be a parabola. 3, 140. I don't know if it will on my ugliness up here. Hey, it even it's working out. Look at that. We got ourselves half of a parabola. And you might be like, well, why doesn't it look very skinny? It's like, well, we went by 20s over here. If we would have gone by 1s, it would be like, doink, right? You'd have to have a really big piece of paper. So going back to when we were talking about time versus elapsed time.
The instantaneous speed at 3 seconds.
Instantaneous speed of 3 seconds is what we're trying to figure out. Before we figured out the speed,
What's the spontaneous?
right? We took this 144, that was the distance after 3 seconds, and we divided by the 3 seconds, right?
So would you take the chunk out of it and divide it? I don't know.
So you're getting close to the right idea of taking a chunk out to look for instantaneous speed. So if I said, what was the speed between 2 and 2.5 seconds? Here's 2.5. What was the average speed in that little chunk?
Divide the top by the bottom?
Yeah. The total time is still, time right here is 2 and time right here is 2.5. So the elapsed time would be 0.5. You're only talking about a half second little chunk of that.
So you divide the further one from the, or your finish from the beginning?
So yeah, let's say find average speed for 2 to 2.5 seconds. That's where this is comes in. F of t in this case, the original distance where that's like kind of where you started,
42.
would be f of 2. F of t plus h. Well, that's t is 2, but then plus h, the elapsed time is plus 0.5.
So it would be the difference
it's like
between them?
this. Yeah. That's like the proper way of writing it. Because you're just looking at that little half-second piece there.
What? Why doesn't it go away with
What? I changed the question. This is just for average speed from 2 to 2.5 seconds. Just trying to get the idea of the elapsed time. This what f of t plus h means. So you're doing f of 2.5 minus f of 2 over 0.5. Well, we know f of 2 is 64. We could figure out f of 2.5 by plugging it in, right? And we'll come up with a number for our average speed. Okay, that still doesn't give us instantaneous speed. Instantaneous is there is no chunk. We want it right at that point, right there.
So you would just go up and look at it?
That's distance.
Oh.
That's what I was thinking too. It's like, oh yeah, hey, just look at the graph. Boom. No, that's distance. So how are we going to get a speed?
Okay, do distance divided by that time. So you, on your point, do your y divided by your x.
Okay, that's what we did up here. We did 144 divided
Oh,
by 2
God.
seconds. That's our average speed for the whole chunk. What is the elapsed? If I'm just looking at one single point, what's the elapsed time?
3 seconds.
No, the time is 3. What's the elapsed time? How much time has passed? Here, half a second passed when I looked at this chunk. If I'm just looking at a single point, 0. There's none. There's no elapsed time. So if we do distance divided by time, what's happening? We're dividing by 0. Can't do that. So how can we find an instantaneous speed?
Can you just...
Bam! In comes Mr. Limit. Now we have and we're gonna have a way to do this. So we need a time interval. We need an elapsed time. We can't do it with 0 elapsed time. That makes no sense. We're dividing by 0.
You made us think all that hard for nothing.
Well, it was important that you understand the idea of elapsed time. So now we need an elapsed time. So you could say, what would be one way of doing this? Make the elapsed time as small as possible to try to find the instantaneous speed. Wouldn't that make sense?
Yeah.
So just take a really little small chunk right here. Couldn't we do that?
Like 0.1 of a chunk.
Yeah, like 0.1.
But
So let's do that. Here's our Here's our elapsed time.
I'm confused a little bit now.
A little bit, it's gonna be okay. And here will be, we're gonna calculate the average speed. So let's let h be 0.1. So I'm just gonna look at a tenth of a second. And now I could choose my tenth of a second right before that point or right after that point. Doesn't matter, I'll choose it right after. So I'm gonna look at the time interval between 3 and 3.1 seconds. Right, because that'll give me a elapsed time and I can divide, all right? So I'll do, the way I would write this out would be f of 3 plus 0.1 minus f of 3
over
over-
0.1.
We should write, yeah, over 0.1.
Saying at 0.01.
Me too.
What's f of 3 plus 0.1?
3.1.
That's just f of 3.1, which is the distance at 3.1 seconds. This is the distance at 3 seconds, right? If I subtract those, doesn't it give me the total distance I traveled?
Yeah,
from-
but if you do, which is gonna be 0.1, you divide 0.1 over 0.1.
No, it's not going to be 0.1. You're thinking of seconds. This will give you the distance traveled in 0.1 seconds.
But don't you want the distance at 8 and at what specific
Okay.
point?
Back to Taco Bell we go.
Yes, I'm hungry.
Where's that Highway 17 picture?
My coach is so clever, he does.
I don't get it.
I could collect call, but call is what the eagle says. Good call.
Here's our back to Highway 17. We're doing this chunk right here, right?
Yeah.
This would be, if we start it right here, and go to right here, our total distance traveled, let's say this was 20, and this was, I don't know, 4. No, it wasn't 20 miles, it was 15 miles, right?
Yeah.
If you wanted to find the velocity for this interval right here, right? You would take the distance you traveled. So if you ended at 15 miles, and that stop sign before Highway 17 was at 4 miles,
It's 11 miles.
you'd go 15 minus 4 to get 4 miles, right?
11 miles.
11 miles. All this is saying is, you're taking the distance the rock has traveled at 3.1 seconds, here it is. Subtracting from that the distance the rock has traveled at 3 seconds, here it is. And you're going to get the total distance the rock traveled in that 0.1 seconds. Does that make sense now?
Yeah.
Okay. So,
But-
and then we're going to divide by the amount of time it took. So f of 3.1, I got to plug it in. 3.1 squared times 16.
Oh, I get it now. I was like, okay, well, 3.01 minus 3,
No, this is f of 3.1.
which means you have to plug it in
The
and get an
position at 3.1
Okay, that-
seconds. We have to plug it in. Remember function notation? If I just gave you that and said, find f of
You gotta
3.1,
put in the function first and then,
here's your function. Yeah, you have to plug it in first. That's a common error.
You
People go
should've just said
3.1
that.
minus 3. No, it's not 3.1 minus 3. It's the position at 3.1 seconds. So f of 3.1, I have to use this.
Holy
It's 16
bonkers.
times 3.1 squared minus 16 times 3 squared over 0.1. Those are the numbers you're going to actually use.
Can we put like the actual numbers, or do we have to do it like that? Like work out those problems?
I don't know what you mean.
Like solve it at the top?
oh heaven.
Oh, just give me the final answer. What'd you get?
Well, I just got 153.76 and then 144.
Yeah,
Nice.
153.76 minus 144 divided by
I
0.1.
got 90.
97.6 is what we should get.
I feel.
So that gives us the average speed of just that little 0.1 section of time, 0.1 seconds. So that's almost an instantaneous speed, isn't it? Could we get a little more accurate?
Sure,
How could we get more accurate?
make it bigger,
Make what bigger?
your interval time.
Bigger? So we're gonna look at a more wider area?
No.
Do 0.01.
Do 0.01, make it smaller, right? If I said, how fast were you driving to Taco Bell?
He does say weird.
Taco Bell.
Taco Bell.
I want exactly the moment of time when you were on the bridge going over the Lynn Coulee, right? You would just look at it that exact moment. You want to look at, well, that 1 mile region where I was going about, down the hill I was going this fast, and then, right, you know what I'm talking about? You wouldn't want to look at a big spot, you want to look at that moment in time, right there. So you make the elapsed time, the area you're looking at, you make that smaller. So if we go 0.01 now, we're going to get more and more accurate. I'm going to save you some trouble. This takes forever to type in, because now we have to do f of 3 plus 0.01, right? Blah, blah, blah.
I'm not going back in my.
It's the same calculation. You'll get 96.16. But hey, wait, I can be more accurate. I can do 0.001.
Oh my
And
goodness.
I can plug it all in, and you'll get 96.016. But I can get even more accurate than that and go
You get
0.0001.
96.0016.
96.0016.
It's a
Wait,
speed.
But I
I
can
don't
get-
get why it went 97.
Insane.
It's just how it worked out.
Because it was, I don't know.
You're too smart.
If I do that, well, if you plugged in the numbers, you could sit there and do it. We could take a full class period to sit here and plug in numbers. I
was
did
just
it for you.
Thank
So
you.
0.000.
All right, can you just give us the
01.
thing that we do now?
96.00016. Do you see?
So how do we get that limit?
Yeah, can you take us to the ending now?
Oh, no. Okay, yeah, we're wrapping up here. Do you see what's happening here?
Punchline.
Yes.
Slowly getting more accurate.
Yeah, and
It's getting
so
smaller.
what do you think the instantaneous speed is
96.
at 3 seconds? Yes.
96.
So it is.
So you subtract
96.
1.6 from
So-
the beginning.
So we say as h approaches 0. Think about what that means. As
It's
h.
getting
Or
smaller.
do you want to write it down first and then talk about what it means?
Yes.
As h approaches 0, change in y over change in t approaches 96 feet per second.
That's how you'd write
What is
that.
that? It's a big, there's a lot of meaning in that sentence.
Welcome.
Just saying h. H is elapsed time, right?
As it reaches 0.
As it approaches. You can never have it
Oh,
hit
yeah.
0 because
As
then
it-
you can't divide by 0.
So as it's getting
So as we're
smaller.
getting smaller and smaller, we're looking at the rock from here to here, then we're looking at it only from here to here, and then we're getting smaller. We're almost getting to that exact moment in time. As that elapsed time approaches 0, the average speed or the speed approaches 96 feet per second. That's all that says.
That's how we'd write
This
the
is the
answer.
idea of a limit. Here's a very vague definition of a limit.
Do we have to write this?
You
Or
don't
is
have
this
to
gonna
do
confuse
anything.
us?
You're looking at the output of something, or the y value of something, as the input, or as x, approaches some number. So in the case of our rock, we were looking at the average speed as the amount of time was getting really, really small. We're looking at the smallest amount of time possible to get an accurate average speed. And that's what it is. And the way we write it, actually, we're almost there. So in our rock example, the way we would actually write that is we would write, the question would say this. That's cursive. It says limit. LIM.
What's that?
Huh?
2 or 3.
This is read the limit as t approaches 3 of the function f of t equals whatever.
You said we weren't going to take notes. I've already filled up 2 pages.
Good job. didn't get to graphs. Dang it. Here's just a general case. The way you read that, because you got to be able to read these right, is the limit as,
X approaches C.
or we could say the limit of f of x as x approaches c, or the limit as x approaches c.
Is L. Is it change of R with a change of
f
X?
of x is L.
Oh, yeah, change of
No.
Boy, we didn't get the graphs, dang it.
That's
We-
the week, yeah.
I felt like we made good progress though.
It was a step in the right direction. Let's-
Is she giving out
Friday,
little,
homecoming.
is she giving out little Caesar spoons?
I should probably know this, we don't.
Yeah, I got you.
Hold on, I gotta make sure you can do these. Oh, yeah,
She
2,
said something
4,
about we have to,
7,
we were supposed to give out papers to you guys.
I know, we gotta make sure you take did it.
I was gonna say, I just don't text me to do it, and I never did.
That's why I was asking if, we were getting
Get
those
our
because
packets,
that's,
probably, yeah.
yeah,
Wait, do we have a meeting tomorrow?
no,
No,
next.
next Friday.
That's it, that's all I can do.
Yeah.
So number 2 is finding average speed. So you're gonna do the thing you did up here, right? You're gonna wanna hear all this before you put all your stuff
I
away.
gotta do it.
So when you're doing your average speed, it's just changing y over changing t, right? The final position divided by the time it took to get there. That's number 2. Number 4 is gonna ask for the instantaneous speed.
Did you,
You could use your calculator on that one and just make your moment of time really, really small. Do like we did there. I would just start small, right? And then you're probably gonna get
5
as
zeros?
close to the answer as possible. On 7, 11, and 9, 7 and 11, they're gonna give you problems like this. This is the limit as x approaches like 1 of, and there's gonna be a function. And you're gonna have to find it. The way you do that, the easiest way you do that, as x approaches 1, in this case, we can do this problem by just plugging in 1 to the equation. Because if x gets really, really close to 1, I can do it. Before, we couldn't just plug in 0, because as h approached 0, we were dividing by 0. You couldn't just plug it in, right?
but now that it's.
So we had to
one,
get, but now that it's okay, as x approach, you just go 1 to the third plus 2 times 1 squared minus 5 is 1 plus 2 minus 5 is negative 2.
So the limit of that is negative.
It's negative 2. Because as x gets really, really close to 1, if you looked at the graph, the y value wouldn't get really, really close to, it would go right to negative 2. Sometimes limits are
So
really
plug
easy.
in, okay.
It's just plugging it in. It's when you can't plug it in and have it work, that's when the whole idea.
So what's 19?
Doing what we did before, where you're going to plug in 0.1, 0.01, 0.001.
So basically when it's 0, you're screwed, but when it's anything else,
You're not.
If it's a fraction, like before, if you're dividing by 0, then you can